Welcome, Algebra 2, to vertical asymptotes and other vertical discontinuities. A discontinuity is a gap. Think of that as a gap. It means discontinuous. Makes the denominator equal 0. It could be an asymptote, or a hole. And an asymptote you guys have seen before. It's where the graph almost looks like it goes vertical or horizontal. In this case, vertical. And there's a break in the actual line itself. So here's my graph, and those goes, whoa, oh my gosh, where am I going? And then from here it goes, oh my gosh, where am I coming from? And then it goes, whoom, off to the side. So this is a vertical asymptote. And when your equation looks like this, your vertical asymptote is at your h value. So x equals h is your vertical asymptote. And do remember to flip the sign that you see in the equation. Don't forget that part. And these graphs will not have holes on them, so you don't have to worry about hole right there. For example, let's say I had a function that looks like this. So a nice little rational function. Here's my h, here's my k. So my vertical asymptote, I'm going to look at this number. Remember to flip the sign. So my vertical asymptote is going to be at -1. Simple enough. So what about if my function looks harder? So what if it looks like one giant fraction? Got a few steps to follow here. First, set the denominator equal to 0. So just pretend I have this, and I set it equal to 0. And then use polyroots to find the real roots. You could factor it if you want to. But I suspect most of you are just going to be, or you could even graph it to find the zeros. But I suspect most of you will be wanting to use polyroots. So, oh goodness, that's a bad glare on that calculator. Let's do like that. How about that? That's a little better. So menu, algebra, polynomial tools, find roots. And this is degree 3 because my biggest exponent is 3. So make that a 3. Press enter. And then put in your coefficients. Don't forget the negatives. 1, -2, -5, 6. Press enter. And my real zeros are -2, 1, and 3. So let me write those down. So that means these 3 numbers are either asymptotes or holes. So now I got to find out which is which. So check these values on a graph. Are they asymptotes or holes? Who knows? Let's see. You would type that whole thing in to a graph, but I've already done it for you. So let's check that out. There's my equation, same one. And you can tell the asymptotes right away because you can see where the graph almost goes vertical. It's not quite vertical, but from this view, it actually looks like it is vertical. And that's at -2 right here. So this right here, that's an asymptote. In fact, I'm going to list it here. Vertical asymptote, x equals -2. And then I saw another one. I saw another vertical asymptote right here. Let me try to block that light. Right there. See, the graph almost goes vertical again. And that's at +1. So that means I have another vertical asymptote at 1. So that's you. Yay! Now the last one is +3. And I don't see anything weird happening at +3. So I've reprinted the graph here for you already. Notice that on this picture of it, I've told you, I've pointed out here, this view is actually from Desmos.com. It's not from a TI Inspire. Then it shows you the undefined value there. That means you have a hole at 3. So on here that looks like, so go to trace, menu, trace, graph trace, and then just type in 3 and press enter. And it won't show you a cute little circle like that, but it does show you this line where it's trying to find the point for you and it can't because it's undefined. So that undefined when there's no asymptote is a whole. So that's that. Cool. So you're going to try this one mostly yourself, but we're going to do it kind of in stages. So first find all vertical asymptotes and discontinuities of this function, and then give the domain. First, I want you go ahead and set the domain equal to 0. Well, let's just do that together. Set the domain equal to 0. Equals 0. And then use polyroots or graphing or factoring to find the real zeros. So go ahead and do that. Use menu 331 or graphing if you prefer. Find the zeros, and we'll be back to check. You should have gotten something like this. So your real roots are -3, -2, and 1. Now you're going to graph this. So go graph it right now in your calculator, and you're going to figure out which ones are asymptotes and which ones are wholes. And I'm going to do that too, and we'll be right back. Hopefully you got that -3 is an asymptote. You can see that right there. There's x equals -3, and we got the graph going almost vertical. Same thing at +1, graph going almost vertical. And then at -2, it looks like there's nothing special going on. So let's see, menu, trace, graph trace, type -2 and press enter. And oh, it's undefined. So even though it looks like the graph is normal, it's not. It's got a gap in it at a -2. So that is a whole. For your domain, all you do is this. You write x is any real number except for these three. You put x not equal to -3, and a lot of times you'll just see it listed like this in order with commas. And there are different ways to write that, but it's the most common you'll see in this class. And that's your domain. X is any real number except for these three. Bam, that's it. That's it for vertical asymptotes, and thank you for watching.